This is Lesson 313, Indirect Measurement, Part 2. And still got the little same cartoon up there because Bob's not Mr. Right. And last time I said that the red triangle represented the red triangle. The red triangle represents the girl. Please don't forget to give me your course and section number with all communication. This helps me help you faster. If you're not sure what your course number is, please look in the upper right hand corner of your geometry LMS. It'll give you your course number and your section number. And so you need to give that to me with all communication. The objectives that we're going to discuss in this lesson are to use triangle similarity to measure distance indirectly, and we kind of did that in the last lesson. Use proportional relationships to find missing side lengths in triangles, and we did that in the last lesson as well. And to identify proportional relationships between side lengths in triangles. And we're going to do this just like we did in the last lesson, but we're just adding a new theorem to get it all figured out. It's in triangles. Alright, we've already discussed Theorem 8.5, Proportional Angle Bisectors Theorem. If two triangles are similar, then their corresponding angle bisectors have the same ratio as their corresponding sides. We even worked some examples in the last lesson of this, on that. And then we're introducing Proportional Segments Theorem. It says an angle bisector of a triangle divides the opposite side into two segments that have the same ratio as the other two sides. Here's some examples of angle bisector. Here's a straight angle with the bisector. See, the straight line is the straight angle, and this is the bisector right here. Here's a right angle with the bisector, so that means each one of these angles is going to be 45 degrees. Matter of fact, each one of these angles up here is going to be 90 degrees. If it's bisected, it means it's 180. Remember, bisect means to divide into two equal parts. So each one of those angles is 90 degrees now. Down here we have an obtuse angle with bisector. I'm not sure what the angle measure is. Looks like it may have been 120, something like that. Say it was 120. These two angles with the little tick marks, those would now be 60 degrees each. Over here we have the acute angle with the bisector. Let's say it's 20 degrees. Now each one of these angles is going to be 10 degrees. So remember, a bisector will divide the angle into two congruent parts. Our angle bisector will be two congruent angles. Alright, the corresponding angle bisectors of two similar triangles have the same ratio as the triangle's corresponding sides. And I took this picture right here and then I set up a proportion to show you what the ratios would look like. The numerator here is JH, that's the angle bisector, so JH right here in the numerator. And then we've got MQ, which is the bisector of the larger triangle, right here in the denominator. Then over here in the numerator we have JK, which is a side of the smaller triangle. And in the denominator we have MN, which is the side of the larger triangle. Now this can be used to find missing links in triangles through indirect measurement. So, and like I said, we've already done some examples showing that in the previous lesson. Okay, so let's look at this example on proportional segments. It says solve for x, and it shows that here we've got 9 centimeters, AD is x centimeters, and down at the bottom DC is 12 centimeters, and BC is 20 centimeters. So I set up the proportion just like this. I said, okay, we're going to do AD, which is x down here, over CD, which is the 12 centimeters. I'm going to set it equal to AB, which is 9 centimeters, over CB, which is 20 centimeters. Now I want you to notice here, there's two triangles here. Okay, the angle bisector, we're dealing with one big triangle. We've got this angle bisector that's created two triangles. So we're trying to figure out what this part right here measures now. Okay, so let's move on to the next step. I substituted AD with the X, CD with the 12, AB with the 9, and CB with the 20. And then did the cross multiplication. So I got 20x equals 108, and then you divide both sides by 20, and you get x equals 5.4 centimeters, which sounds pretty good. And the way to check that is to set these set up the ratio again, cross multiply, and make sure they equal each other. Okay, let's go ahead and work some examples here. Let me make sure I've got the proper ink color. Make sure I've actually got the pen turned on. Okay, now let's go through here. Remember I told you in the last one, whatever they mention first is going to be your numerator. Whatever they mention second is your denominator. So we're going to set up our proportion. Now these are two separate triangles with angle bisectors. And remember they told us that this altitude, actually the bisector, is proportional. So those guys are proportional. And then they gave us the measure of these segments, and those guys are proportional too. So that's how we can set up our proportion. Let's just say MO over XZ. See how I put the larger triangle in my numerator? And then I'm going to have LM over WX. Then I'm going to substitute the values. So for MO, we have 14. And for XZ, we have 6. For LM, we have X plus 4. And for WX, we have 3X minus 2. Alright, now you cross multiply. So I'm going to have the 14 multiplied by the difference of 3x and 2. I'm going to set that equal to 6 multiplied by the sum of x and 4. So this is how we're setting it up. 14 multiplied by 3x minus 2 equals 6 multiplied by the sum of x and 4. So remember, when you do this, you have to distribute. Whatever's outside the parentheses has to be multiplied by everything in the parentheses. So this, I'm making sure I was looking at the right thing, is 14 times 3 is going to give me 42, and I bring down my x. 14 times 2 is going to give me 28. 6 times x is 6x. 6 times 4 will give me 24. Now I like to keep my x's positive, so I'm going to subtract 6x from both sides. So that gives me 36. X minus 28 equals 24. Then I'm going to add 28 to both sides. And I get 36x equals 52. Then I'm going to divide both sides by 36. Ooh, that is not going to be a pretty answer. I get, all you can do is just reduce that. You can put it in your TI-84 calculator or TI-83. Type in your fraction, 52 divided by 36. Then push math, enter, enter, and it'll give you the reduced fraction, which is 13 over 9. So this x right here, if I wanted to figure out those measures, I would say 3 times 13 over 9 minus 2, and do the same over here, 13 over 9 plus 4. and that would let me know what the measures of those segments were. Okay, let's look at the official answer. Looks a lot shorter than mine, but see how I added in all the little steps for you, because a lot of students are still struggling a little bit with the algebra, so they're curious as to why this says 14 times 3x. How did they get from that to all of this in this row? So I like to include all the steps so you know that I did the distribution and combine like terms, and then use the addition property to move everything to the other side of the equation, and so on. Okay, let's do another example. This one is using the Proportional Segments Theorem to find x, which says if I've gone through and used this angle bisector and created these two triangles, I'm still using the same similarities, okay? Now, we don't know exactly which ones to use in the numerator and denominator on this one. So let's just use this first one here. Let's call it my numerator. We'll call this triangle my denominator. So when I set up my proportion, I'm going to say these guys are proportional, and these side segments are proportional. Alright, so I'm going to have LO over ON equals LM over NM. And remember, I've told you it's very important to write down these letters like this. It helps you keep everything organized and catch any mistakes if you're going to make them. Alright, so LO I'm replacing with 10. ON I'm replacing with 4. LM is X, and NM is 12. So you do your cross multiplication. 10 times 12 is 120. 4 times X is 4X. Divide both sides by 4. And 120 divided by 4 will give me 30. So this X right here equals 30 centimeters. And there we go, official answer. Okay, just to summarize this lesson, we worked again with the proportional angle bisectors theorem, and we also worked with the proportional segments theorem. And remember, the proportional segments say, hey, if there's an angle bisector in a triangle, it's created, that angle bisector created two triangles now, and those triangles are also similar, and their sides will be proportional. So just giving you a whole lot of different ways to solve similar triangles. Okay, what you should be doing after this video lesson is reading through the LMS lesson 313. I believe there's a proof in there, and they may have given you a couple more examples. Also read through the lesson and the reference guide, and complete the following problems in the problem set. Looks like there's only 4 of them. And if you have any problems understanding those in the practice problem set, then we need you to either contact me or go attend TOGA on Monday through Thursday so you can get your questions answered and you'll be able to do well on the quiz. Okay, that's going to be it, and I appreciate you listening to the